Guys, it's the final video. My dogs are freaking out because I've been recording videos for over an hour. It's chapter 19, comparing counts. They really don't like it when I talk to myself, apparently. And this is going to be the chi-squared test for independence. So remember way back in Unit 1 where I said we were going to try to figure out if variables were independent in Units 1, 2, and 3? Well, here's the time when we can decide if the two variables are independent in Unit 3. So we are given a distribution of two categorical variables at the same time. Everyone's favorite, this is referred to as a contingency table, right? There's one variable expressed as rows and one is expressed as columns. So we're given the distribution of two categorical variables at the same time and asked if they are independent. And what does independent mean, right? Unrelated or related is really what we're being asked. Okay, so unrelated would be independent, related would be dependent by definition of your text. All right, so the way that this works is we're literally provided with a contingency table and we are expected to go forth and use that contingency table to run a chi-squared test. It is in fact mathematically literally no work for you. It does take a little bit of getting used to in the calculator. So let's discuss the hypotheses. Remember that these are in words for chi-squared tests. So we literally go with like blank and blank are independent. You're going to love this. The alternative is blank and blank are not independent. And then we actually put the entire contingency table. You put the entire contingency table into the matrix function of your calculator. And it does all the work for you. It is awesome, okay? So the trick here is that you do need to know a few things like how to find the matrix and all that good stuff. So I have notes. I want you to go visit my Unit 3 notes under Professor Bell's Unit 3 materials, and those notes are going to truly help here. To access Matrix A, there's also calculator instructions provided for you under the Learning Materials page. There's one major difference between this test and the other test, and it's the degrees of freedom. Besides the fact that in our calculator, we're going to run a chi-squared test. That's all we're going to do. Everybody's calculator has this one. We put the we put the observed in matrix A. Expected, it actually by default will fill in matrix B for you. You will never have to fill this in. We actually never tell it the degrees of freedom, but I will give you that equation. And then the output is the chi-squared and the p-value. Okay, so I just have one more note on the next page. I'm going to make a fake contingency table and just show you something, okay? So let's just pretend it really doesn't matter what's going on. I'm not trying to make it serious, right? This is just category A, B, and C, and category D and E, right? Okay, So the way that this would look in the calculator, in the matrix, is that it would actually mimic this. You would go to matrix A and you'd be able to enter it as and you go row by column. So this is a 2 by 3 matrix. It's 2 rows by 3 columns. And you'd enter it like this, row by row. So you'd hit 3, enter, 7, enter, 11, enter, like that. And 5, 9, and 13. And you'd run the chi-squared test on A. Okay? So then we would make our conclusion using our p-value and comparing it to our alpha level. I want to make one more note. Note, you cannot check, that dog is so loud, the expected cell frequency condition until after you run the test in your calculator. What happens is matrix B auto-populates with expected counts. And we can access matrix B by going to the matrix feature and looking at the values inside of it after we run the test and find the p-value. Okay, so it's a strange chapter just because it's very different from the previous tests. But please, as always, follow up with my examples so you feel like you have a really good understanding of what's going on. And comment if you have any questions for me at all.